Please welcome Chief Executive Officer, Bentley Systems, Nicholas Cumins.
It's a beautiful day. Good morning, everyone, and welcome to day 2 of the 2024 Year in Infrastructure. I hope you all enjoyed yesterday's finalist presentations. What a remarkable display of innovation. Each project showed us how infrastructure is advancing right in front of our eyes. It's clear that the future is being shaped today. So I don't know if there is any William Gibson fan in the audience today. Oh, a few, there you go. He's a science fiction author. He's known for writing Neuromancer, among other great works, and he actually lives here in Vancouver. Perhaps his most famous quote is, "The future is already here, it's just not evenly distributed." And that's exactly the spirit of YII, to showcase what's possible and to inspire others. And what better place to be inspired than here in Vancouver? This is a city with a long history of sustaining the equilibrium between the built and the natural environment. For over 10,000 years, its infrastructure has evolved along the changing needs of its people, from the wooden longhouses and pathways built by the Coast Salish peoples, to the timber trade and the railroads that shaped its early modern economy. It's a unique city at the frontier here in the Pacific Northwest. Now, almost 40 years ago, Vancouver was the venue of Expo 86 World Fair. And you can see many of the structures that became iconic on that picture behind me. The theme was, and how appropriate, the theme was transportation and communication. World in motion, world in touch. This was a significant milestone for Vancouver, showing its forward-thinking approach to infrastructure and global connectivity. And around the same time, Bentley Systems was beginning its own journey in Pennsylvania, driven by that same commitment to advancing the world's infrastructure. When Bentley was founded in 1984, Keith Bentley recognized the potential of the personal computer as a major paradigm shift in engineering software. He saw a PC as a way to make CAD software more accessible to more people. And with MicroStation, Bentley gave engineers the tools to help them work more efficiently, more precisely, forever changing the way infrastructure was designed. As the technology evolved, so did our approach to design. We went from 2D to 3D. We gave the engineers the ability to visualize their project in a more realistic way and to better solve problems before construction began. The Bentley applications helped drive this shift, empowering engineers to bring increasingly more complex designs to life. In the early years of internet, ProjectWise and AssetWise transformed the way projects and assets are managed. These web server-based solutions enable the teams to collaborate seamlessly, giving colleagues and stakeholders real-time access to project and asset data, no matter where they were. It improved coordination. It ensured that everyone worked from the same accurate information. Then came the fourth dimension, time, with 4D construction modeling. With Synchro, engineers could plan and model the sequence of a construction project and leverage that model to track progress from beginning to end, ensuring construction stayed on time and within budget. Next, with iTwin and digital twins, we took it even further. Digital twins, dynamic replicas of infrastructure assets that are continuously updated with real-world data, allowed engineers to monitor, to manage, and to optimize their assets throughout the entire life cycle, maintaining or even improving their performance over time. For 40 years, Bentley has successfully leveraged technology to improve the way engineers work, to improve asset performance. And Today, we are on the cusp of a new paradigm shift: artificial intelligence. Artificial intelligence is transforming every industry, and infrastructure is no exception. Just imagine the sheer scale of data that is created in the design, the construction, and the operations phase. It makes infrastructure a prime area where AI can have the greatest impact. At Bentley, we've been investing in AI for years. We've recognized its potential early on, and we've implemented it successfully in use cases in asset operations, incorporating computer vision and machine learning. AI-driven insights allow operators to predict when maintenance is needed before failures occur. AI agents analyze digital twins of infrastructure assets, whether bridges or roads or dams or water networks, to identify issues and recommend preventive action, avoiding costly breakdowns and safety hazards. Take road maintenance as an example. We are using crowdsourced data, applying AI to it to identify issues before they escalate. No longer do we have to wait for a problem to arise. We can anticipate and address it before it disrupts traffic. But when we take a step back, AI has a huge potential in the design phase of the infrastructure lifecycle. AI can automate repetitive tasks like documentation or annotations to free up the engineers to focus on higher value activities. And AI can also act as a co-pilot, suggesting refinements to make the designs more effective, for example, more carbon efficient and better suited for the future challenges. At the end of the day, AI's true power will be measured by its ability to improve outcomes. More sustainable designs, faster and safer builds, and more reliable infrastructure systems. As we look to the future, the possibilities seem endless. But to begin to understand what's possible tomorrow, we need to be clear on the state of the industry today. And infrastructure today is facing unprecedented challenges. Around the world, demand for better, more resilient infrastructure is surging, whether it's to expand the energy grids, or to modernize transportation networks, or to retrofit existing structures to meet the Sustainable Development Goals. These are massive undertakings, requiring trillions of dollars of investments and decades of effort. We are hearing this from you firsthand. Despite the urgent needs, there are not enough engineers to meet this demand. Your backlogs are growing, they're extending further out, your projects are stacking up. The shortage of skilled engineers and technical professionals is widening the gap between what is needed and what can realistically be delivered. While we have a shortage of demand, we have no shortage of data. And there lies the biggest paradox of our industry. We have so much data, but comparatively so few insights. So many assets generate gigabytes of data every day, whether from sensors on a bridge or utility network or any other system. But only a small fraction of that data is ever analyzed. Some say 10% of the data collected is used. Others say not even that much. And the reality is that in order to take advantage of AI and other innovations, you need to get control of your data. So let's tackle the first challenge first, the gap between the growing demand for resilient infrastructure and the shortage of engineers to do the work. We can't build our way through this. The focus of sustainable development must shift to adapting and optimizing the infrastructure that is already in place. More than 95% of the infrastructure that will be in use in 2030 already exists today. So the pressure is not just to deliver more infrastructure, but to ensure that the infrastructure that we already have is resilient, is efficient, and is capable of meeting the demands of tomorrow. Now, of course, the starting point is to have a better understanding of existing infrastructure. And as always, our users are showing the way. Here are 3 examples of projects that were submitted in this year's Going Digital Award. The Bridging Kentucky program set out to inspect and fix 1,000 deficient bridges. Now, based on past experience, this could take over 10 years and cost more than $700 million. To speed things up, the survey team led by QK4 used iTwin Capture and Open Roads to create 3D models of over 700 bridges. With Bentley software, they finished the survey 90% faster and cut costs by 50%. That's 90 and 50. They created digital twins that design engineers can trust and use for construction plans, setting new standards in bridge surveying, design, and construction. Also, exactly. Also in Kentucky, the Ohio Falls Hydro Station includes 2 towers that were built in the 1920s, supporting a transmission line across the Ohio River. The utility company decided to reuse those towers instead of building a new crossing in another location. They hired EXO to inspect those towers, using iTwin Capture to process 250 gigabytes of drone photos into a reality mesh. And the resulting digital twin allowed EXO to assess corrosion and structural stability, identifying the best way to reinforce the towers. As a result, they avoided a potential 10 years of permitting delays and saved about $80 million compared to building a new tower crossing. And on the other side of the world, in Singapore, the Public Utilities Board has a smart water grid program to monitor over 6,000 kilometers of pipeline. While they use sensors, these only cover part of the network, so they still rely on labor-intensive field surveys. Now, to improve this, PUB combined open flows with AI and ML, creating an integrated leak detection system that uses sensor data to update the hydraulic models on a daily basis. This new approach helped them find 2 major underground leaks between January and May of this year. These are powerful examples of how software has been used to gain a better understanding of the existing infrastructure. They're also a validation of our strategy to make asset analytics a priority going forward. To bring clarity to this strategy, we are combining existing products and solutions, new innovations and acquisitions into a new product portfolio, which we call Bentley Asset Analytics, which leverages AI to generate insights into the operating conditions of the existing infrastructure assets. Our aim is to cover a wide range of asset classes and data capture techniques, whether through IoT sensors or drones or dashcam or other cutting-edge methods. We extend an invitation to engineering firms to partner with us on this. We want to empower engineering firms to extend their expertise into asset operations. We know that delivering on the promise of AI-driven asset analytics requires close collaboration. Now, the true power of asset analytics comes to life when integrated into a digital twin. A digital twin is more than a dynamic model. It's a digital thread that weaves together data from various sources, creating a clear and evolving view of your infrastructure. This digital thread allows you to connect data from IoT sensors, subsurface exploration, satellite imagery, enterprise systems, and more, aligning all of this information to provide the full context needed for smarter decision making. Let me give you an example. It is common to undertake facilities checks after an earthquake. This generally involves sending out specialists to do manual assessments, sometimes after the shaking has stopped. Now, consider the value of picking up just a few millimeters of ground movement near an aging dam before a significant earthquake event, so that mitigation action can be taken. By connecting real-time data from remote sensors to the subsurface model, engineers can rerun slope stability assessments and define the appropriate mitigation measures. This is a great example of how, by combining data from different sources, unique insights can be generated, which in this case can dramatically reduce risk on a critical infrastructure asset. So let's take this a step further. One of the most exciting recent developments in our journey of advancing infrastructure is the integration into the digital twin of 3D geospatial capabilities. Since launching iTwin more than 5 years ago, we have learned that a 3D geospatial view is the most intuitive way for owner-operators and engineering services providers to search for and create information about infrastructure networks and assets. After all, infrastructure is of geospatial scale. So with the acquisition of Cesium, we're now able to provide a 3D geospatial view of infrastructure. We are effectively changing the vantage point of an infrastructure digital twin from the engineering model of the infrastructure asset to the planet Earth, upon which we geolocate the engineering model and all the necessary data from the surrounding built and natural environments. The combination of Cesium plus iTwin enables developers to seamlessly align 3D geospatial data with engineering data, subsurface data, IoT data, reality data, enterprise data, to create digital twins with astonishing user experiences that scale from vast infrastructure networks to the millimeter accurate details of individual assets, viewed from land, sky, and sea, from outer space to deep below the Earth's surface, to support engineering workflows. But perhaps the most significant aspect of Cesium is its alignment with Bentley's visions of open standards and interoperability. This means organizations can integrate external data sources, third-party tools, their own analytics into the digital twin. We are not creating another silo. We're enabling ecosystems where data flows securely and enhances decision-making at every level. As we advance towards more sophisticated asset operations and AI-driven insights, one thing has become abundantly clear. To unlock the full potential of these innovations, we must connect them to broader data ecosystems. Infrastructure projects are notoriously complex. They involve multiple organizations, multiple teams, multiple engineering disciplines, multiple stakeholders, working together over extended periods of time. This complexity makes it impossible for you to rely on any single system or single vendor. Instead, you need an ecosystem that enables flexibility, integration, and interoperability across different tools and platforms. At Bentley, we understand that openness is not just a feature, it's a necessity. And we've acknowledged that from the start. That's why our Bentley open applications are by design open. These applications allow you to edit models from other vendors. This gives you the flexibility to use the software that fits your needs while still enabling collaboration across teams. Now, this openness is also vital given the very long life cycle of the infrastructure assets. A road, a bridge, or a dam might be in operation for 50 years or more, undergoing repairs and upgrades and expansions. During this time, the software and platform used to manage these assets will evolve. So by ensuring that our systems remain open, we allow organizations to adopt new technologies and innovations while still being able to access and build on their historical data. Your data is your data always. But openness isn't just about connecting different software. It's about structuring and organizing data in such a way that it can be queried, it can be analyzed, it can be reused across different platforms. This is where Bentley's base infrastructure schema comes into play. So, let me go deep on this subject for just a moment. Over the past 10 years, we have developed a robust open source schema specifically for infrastructure. It is a mature, proven framework that goes beyond basic data exchange. Our schema ensures that data isn't just accessible, but its meaning can also be understood. Whether you're dealing with materials or structures or subsurface data, the schema organizes information in a way that enables engineers and constructors and organizations to reuse and fully leverage the value of their data. And we're not keeping it to ourselves. We actively encourage others in the industry to adopt the schema. This is about moving the entire infrastructure sector forward together. We have spent years refining this schema so that organizations don't have to start from scratch. And we welcome others to benefit from its maturity and richness. By ensuring that the data aligns to a common schema, we're allowing infrastructure teams to work better together and to make better informed decisions. Openness is what will drive infrastructure forward. And a perfect example of how we're expanding the boundaries of openness is our partnership with Google. Today, we are proud to announce an exciting new strategic partnership between Bentley and Google, a partnership that is based on a shared vision of sustainable infrastructure. By integrating Google's geospatial data into Bentley's applications and platforms, we're elevating our capabilities to a whole new level. Google's massive scale of geospatial data is unmatched. When this data is combined with Bentley's infrastructure engineering expertise, the result is an ecosystem where data can flow seamlessly, providing users with the most comprehensive and actionable geospatial insights available. Consider a large urban development project where multiple infrastructure systems are used, roads, bridges, energies, and water networks that must be coordinated across various stakeholders. By integrating Google's vast 3D geospatial data with Bentley's Cesium technology and iTwin platform, stakeholders can visualize their assets, both existing and planned, in full real-world context. This integration enables teams to make better informed decisions about everything from design to operations, from improving project outcomes to reducing the risk of service outages. This is not just about accessing more data. It's about making that data more meaningful and useful. What we're looking at here is HS2, the high-speed railway under construction in the UK. To support the communities and stakeholders, the BBV joint venture developed an in-house application in Unreal Engine using Bentley's iTwin plugin, which allows parallel streaming of multiple models containing the current design. Users can navigate quickly to any asset of interest. They can generate imagery and view fly-through videos. The Cesium plugin allows the streaming of Google's 3D photorealistic tiles to aid navigation and embellish the iTwin content. Amazing, isn't it? Our partnership with Google reflects the reality within infrastructure. The reality is that no single vendor can address the complexity of today's challenges alone. By bringing together the best of both worlds, Google unmatched geospatial data and Bentley's industry-leading infrastructure engineering software, we are creating open ecosystems that allow organizations to access the tools, data, and insights that they need whenever they need them. We are unleashing the potential of 3D geospatial data for infrastructure. You can no longer afford to work in silos with data that are locked into proprietary systems. The infrastructure of tomorrow requires the data to move securely between system and stakeholders. Whether it's the integration of 3D geospatial data through our partnership with Google, or the seamless connection of asset data into the digital twin, we are committed to creating the open, flexible data ecosystems that you need to succeed. The future of infrastructure engineering is open. It's flexible, collaborative, and built on a foundation of data that you can share securely. And at Bentley, we are leading the way. We are making sure that the applications, the platform, and the solutions that we create meet the evolving needs of our industry. As we look forward to the next 40 years, the challenges we face are immense. There is no shortage of demand, yet there's a shortage of skilled engineers. There is no shortage of data, yet there is a shortage of insights. The key to moving forward, the key to harnessing the paradigm shifts of the next 40 years is to unlock the value of the data. So don't get locked in. Make sure you retain control of your data. Let's use AI, our generation's paradigm shift, to improve outcomes for the built and natural environment. As to the future, borrowing the words of the visionary computer scientist Alan Kay, the best way to predict the future is to invent it. The decisions we make today at Bentley's 40-year mark will shape the next 40 years of infrastructure. Together, we're laying the groundwork for a future where open data ecosystems and AI seamlessly work together to create more sustainable and resilient infrastructure for better quality of life for generations to come. Thank you.